Doppler effect for mechanical waves. The Doppler effect is the way that waves seem to stretch out or compress when objects move at different relative velocities. So let's look at what relative velocity or what relative motion means. So relative motion is the continuous change in position of one body with respect to a second body. When we refer to the Doppler effect, we talk about two bodies. So we call one of them the observer, which could be me or you, and then we call the second body the source. Now, relative motion is when these two bodies are moving with respect to one another. So for example, if the source is moving away from the observer, we say there's relative motion between the two bodies. Or the observer could be moving towards the source. Okay? This is relative motion. So let's look at an example of the Doppler effect. So when the Doppler effect doesn't apply, this is when there is no relative motion. Okay, no relative motion. We have our observer at the edge of this pond or at the edge of this wave source. Okay, so this is my observer, and then I have my source. Okay, this is my source. So since these two are not moving, there's no relative motion between the two, the Doppler effect doesn't come into play. So as you can see, the waves, the wavelengths of each of the waves is completely constant and does not change. Now, let's see what happens when there is relative motion. So in this case, we have source moving away. Okay? So since the source right here, again the source, and this is the observer, since the source is moving away, you can see what happens to the wavelength. The wavelength increases. So the wavelength increases. And since the wavelength increases, the frequency decreases. So if this was a sound source and it was moving away from the observer would hear a lower frequency or a lower pitch. It would seem lower. And let's see what happens when the source is moving towards. So in this case, source moving towards. So as it's moving towards, again, this is my source and this is my observer, what happens to the wavelengths? The wavelengths become compressed. So the wavelengths become smaller and the frequency thereby increases. We see the Doppler effect all the time. Stand out on a sidewalk or stand out by a busy street. When you see cars zooming by, okay, if a car hits its horn, it's producing a sound source. So as it moves away from you, that sound source becomes lower in pitch. If the cars are driving towards you and beeping their horn, the frequency increases, so it sounds higher in pitch. Okay, here are the important equations. So when a source is moving towards an observer, we have this equation here. Okay, F0 is the original frequency, and then F is the observed frequency. V is the velocity of the wave. Typically, when we talk about Doppler effect, we talk about sound. So this would be i.e. speed of sound. Okay. And then Vs, or V sub s, is the velocity of the actual source. These equations are essentially the same, except when the source is moving towards the observer, you do subtraction in the denominator. When the source is moving away from the observer, you do addition in the denominator. Okay? So when it's moving away, the frequency will decrease. When it's moving towards the observer, the frequency will increase because of these denominator changes.